Good to go?
Yeah, I think so. It's 10:01, right? So I think we are good to go.
Excellent. Well, I want to thank everyone for joining us today for this exciting release of footForma, the latest innovation from Spenties. I am thrilled to join you with my colleague Gilles. My name is Brian, and I'm on the business development team with Spenties. I'm based here in Georgia. And Gilles, if you'll quickly introduce yourself, and we'll jump right into it.
Hi, my name is Gilles. I'm based in Brussels, where the head office is from Spenties. I'm a occupational therapist at base, so a certified occupational therapist, but working as a customer success for Spenties. So happy to be alongside Brian today to show you the footForma tool we have at Spenties.
Amazing. So if you're joining this webinar, you're most keen and interested in understanding how to modify lower extremity scans with tools and technology that are built for you. Historically, there have been digital workflows that clinicians and technicians have used that are really outside of the O&P industry that have been repurposed for the roles that we have here on the day-to-day jobs of clinicians and technicians. And finally, today you'll see software that is specifically designed for you, from where you could go from a scan of a cast or a limb to a modified mold in minutes. You know, there's these buzzwords of AI and automation and these exciting new technologies that are available to everyone, but not necessarily for O&P. And you'll see today what that looks like from Spenties. Spenties, we are a O&P software developer. We work directly with clinicians and technicians to understand the specific tools that are needed on a day-to-day basis, and then we develop them, provide them, train them on them, and make them available. So today, we're going to have a conversation about footForma. We hope that by the end of this webinar, you are downloading and installing the footForma application so that you could be able to take what you learn in this webinar and apply it immediately. You'll see by the end of it, we have a very simple pathway for you to access this software, and we hope that you will join us in using it. We're going to start with the why. Then you're going to learn exactly how to use it with Gilles opening up the application and going through a live demonstration. What happens after you modify that mold? We'll talk about it. How to get started and Q&A. So any questions that you have while we are sharing any of this content with you along the way, just put it in the chat in the Q&A section, and we'll save time at the end to answer all of your questions live. Now, no Irish goodbyes. Stick with us. As I mentioned, that free access to footForma comes at the end. And just so you know, after your free access is over, it's only $99 a month. I wanted to get that out there up front because it's no gotchas here. After your trial of footForma, it's a very straightforward business model. I'm going to share with you something that we're releasing at OT World. So you're definitely going to want to wait till the end. It's never been seen, never been shown live or really to anyone outside of our small beta users. So you guys are going to get first access here and see what's releasing at OT World, and then we'll be answering your questions live. So why? Why does Spenties continue to release innovative tools and technologies for the orthotics and prosthetics profession across the world? Why do we work and make the complicated easy? And I think it's really important to start there so that you could really understand the foundation of our workflows and understand the core elements of it, so that when you're asking your team, do we want to use something like this, that you really align with not only just the flow and functionality of it, but the why. So very simply put, you guys are seeing more patients than ever before. Chronic conditions and aging populations have your lobbies full all the time. So that's an important piece to really put into perspective, because you have more patients than ever, you have bigger goals than ever, and your objectives to see as many of those patients and provide your innovative care, whether it be clinical or technical, is greater than ever. And there is no sign that it's going to be slowing down. In fact, there will be more in the future. Costs. Now, this is an emotional slide for me because I'm experiencing the rise in cost, just like you are, just like everyone is in the world. In preparation for this webinar, I was looking at the buying power of the US dollar over the last 10 years, and I got a little depressed. The cost that we're experiencing in our world is incredible. And I think if we're trying to apply the same strategies and the same workflows and the same approaches that we were approaching and trying in 2016 and in 2026, with that decrease of buying power of the US dollar, it's a recipe that is really tricky and challenging. So if you're in this webinar, I think you can very much so align with, guys, our prices for everything has gone up. We need to be more efficient. We need to increase our throughput, and we need to be able to address this demand really simply. And that is what we have. That's one of the core elements of our software, is that you could be able to implement footForma and save time, labor, and cost. But in addition to all of that, traditional modification is inconsistent. Depending on the person that is modifying that mold, their experience level is the output that you get. It's messy. This clinician, now I used a little bit of AI here. When I took that photo, and it was just the photo, the clinician was in their regular clinical clothes, seeing patients, but then I added the photo to an AI generator, and it made this big mess because this happens. And when you are focusing on delivering core clinical care and you then have to go to the back and mix up plaster, oftentimes you're going to walk out the clinic that day with plaster in your hair and all over the place. So these are the core elements of the Spentys technology development. We want to address the increase in patient population, the costs that we're all experiencing, and the inconsistencies, the mess, the laborious process of traditional fabrication, so that you could be able to have a workflow that is straightforward. Now, to put it simply, the answer to all of those things is a culmination of a number of technologies like 3D scanning, digital workflow, and advanced manufacturing. That is the recipe that the leaders are looking towards today to address those challenges that we're all facing. We're going to zoom into the digital workflow piece today, assuming that you have a scanner already, and I'll show you access to advanced manufacturing towards the end of this session here. But we're just going to zoom in on digital workflow. But however, not all digital workflows, not all digital technology is made the same. I have one of our partners, Certified Orthotics in Colorado. They started using footForma because before they were using footForma, they had multiple different CAD systems, one of which that had like 30 different buttons at the top of the CAD system. Very complicated to learn, very powerful and very consistent once that individual learned how to use the software. But then when they got to the point to where they needed to delegate and expand access to the digital workflow because they're seeing the value of going digital, they're having to train others in the CFAB, and that learning curve was 6 months long. So switching between all these systems, the manualness of it all, the expertise required to run a CAD system, and the limited standardization These are all pieces that led Certified Orthopedics to us with footForma. And what they shared with us is that this process, this software that we're going to share with you today, has extremely simplified the process for modifying lower extremity scans. It only takes up to 10 minutes for Chase and his colleagues to be able to import a scan and export a modified mold, where with tools like MeshMixer, yeah, it took 15 to 25. It's like I said, a powerful software, but it's complicated to learn and to use at scale. So we're very proud of how Certified has been one of our early adopters of this workflow and is producing hundreds of molds a month. And we are thrilled to share their experience with the tool. But I don't want to spend all day talking through slides and going through word for word the core value proposition. I really want to show you with Gilles opening up footForma and driving the process himself so you can actually see and experience it for yourself. But one core takeaway from this session today, if your team asks you, why did you spend that 1 hour with Spenties? It's because you gained access to a workflow that focuses on quality, precision, speed, at a cost that everyone can access. And that you take back to your team and say, we are ready to take the next step in digital. And Gilles, now I'll pass things off to you. Let's open up footForma, upload a scan, and teach everyone here how to use it.
Okay, thank you, Brian. Can you see my screen? Just to be sure.
Yes.
All right, perfect. So this is the Forma application that Spenties has created. At the moment, I still have to upload my scan, so that's something that I will quickly do together with you. And so the goal here is to provide some information about the project that we're creating, select the scan, and then you immediately have the two products that we have available at Spenties. So the M2 is our old footForma product code, and now we have the new mold, the M3, that we will be able to use. Once we have saved our selection and we have provided some information regarding the scan that we will be using and correcting, we can start with the correction. So here we actually start with the actual footForma software of Spenties. And as you can see, we have clearly separated the whole workflow in 4 clear steps with a very clear goal behind each step. And so in the first one that we will address, this is called the cleanup. This is where we will be able to select the scan or the part of the scan that we actually want to work with, and then move forward to the post correction. The post correction speaks for itself. That's where we will modify the positioning of the scan. Then we have the mold level. The mold level is where we will really create our own digital mold. So we have a few possibilities on how to correct the ankle, how to shape the toe box, etc. And then a final level, which is called the sculpt level. This is really where we can finalize our digital mold in order for it to be carved, for example, or used for further to create your next device. If we start with the cleanup, you can see that the scan is red. The goal here is to select a part of the scan that we want to work with. Sometimes it's possible that we scanned multiple artifacts that we don't need. This is just to indicate which part of the scan we do need and that we can proceed to the next step with. Here at the bottom of the screen on the right side, we have always an indication of where we should place the landmarks. This is a way that Spenties likes to work because with these landmarks, the software will be able to orient itself and create these axes that we can use to crop the scan, for example. I'll zoom out a little bit. So the goal here is to crop the scan at a certain height. At the bottom of the screen, you can see the length from the malleoli onward. And so with these sliders, we're able to change the inclination of the plane at the top of the scan. So the goal here is to just make a nice and clean cut at the proximal calf. And once that is done, we are able to proceed to the next step. Here we see the dimensions of the scan. This is just for informational purposes, but there's another button that we have here on the screen, robust smooth. This is a feature that can be used in case you've scanned a very rough cast scan, for example. In this case, it's quite a clean scan, so there's no need to go over with the robust smooth. But just know that that feature is there in case you would like to use it. So now I can validate, and we've already finished the first step of the footForma digital mold software. If we then start with the post correction, some extra landmarks are requested. On the right side, you can each time see where we should exactly indicate them. The good thing about this scan is that there were already some physical landmarks attached to the scan, so it makes it a little bit easier for me to identify them. And there we go, we're almost at the end. One more. And so now the software will use all of these landmarks that we've placed in order to get a good view of the scan that we've uploaded, and to create axes and digital articulations that we can use in this step to correct the positioning. So now you can see that we have placed the scan on an X and a Y axis, and that we also have this triangle at the bottom of the foot. This is based on the landmarks that we've placed. And so that's something that we can use to make sure that the foot is nicely aligned with the x-axis, with the floor, and then we can start modifying the rest of the scan. So here we have this button which says correct foot to floor, and then the next step would be to align it with the x-axis, as it will give us a lot more visual feedback on the corrections that we're doing. So that's what I'm doing at the moment. You still have to make sure that the triangle is still nicely aligned with the floor. You can zoom in a little bit for it to be a bit more clear. And so now I still have to modify this angle a little bit. There we go. And so now we can start correcting the positioning of the ankle and the foot itself. So therefore we have these 6 sliders. Let's take a look if a foot rotation should be modified. At the moment, I don't think so. So let's start with the plantar and the dorsal flexion. Just by using this slider, we're able to modify the positioning of the ankle into dorsal or plantar flexion. And so the goal here is to go to a neutral position. Same for the ab or the abduction of the lower leg. We can zoom in a little bit. These lines can be used as a reference for the amount of correction that is needed. In this case, maybe a bit more can be used. And so that's the procedure and how to proceed from each slider to the next one. Here we can take a look at the pro and supination of the forefoot. That's also something that we can correct independently. So before we corrected the whole rotation of the scan, in this case we can start, we can do the same, but only for the forefoot. And same goes for the upper adduction of forefoot. And then as last, at the end, we have the heel that we can still correct. So again, here it's the goal to align this dotted line with the axis. And once that is done, we have achieved quite a good neutral position. That's what I'm quite happy with this position. Of course, this is different for each patient, so the amount of modifications or changes that need to be done are different for each patient. So in this case, I'm quite happy with that. But so as you can see, in just a matter of minutes, we already have our corrected positioning, and we're able to start with the mold level. The first step here is to see if we need a global reduction. This is in case you've scanned the cast scan. So in my case, we can reduce the global or the overall thickness of the cast in order to have a more representative circumference compared to the patient's real limb. Once that is applied, we can continue where we will have a bit more sliders to work with. So in the next step, we will have controls for our calf. So the calf reconstruction, we have the heel, we have the toe box, and then we also have the medial arch sliders. I will just give you a walkthrough of the majority of the sliders because there are quite a lot. But so these first two, they can be used to either decrease the height of the calf or increase it just by using these sliders. You can tell by the dotted line, which is the mold that we're actually creating based on the real scan. So here you can see both scans laying on top of each other, where you can clearly see the displacement compared to one another. Or we also work with this gradient, where you can see with the colors the amount of material that has been added or removed. So there are multiple ways of constantly checking your scan. But so again, these two are for deciding on the length of your mold. The straightening can be used to straighten the calf, and the offsets can be used in order to create either a local or a global calf offset. And so as soon as we apply an offset, we can also choose the height where it will be added. So either it's only proximal, or we can also apply it more distally. And same goes for having it gradually going, or having the same offset all along the calf. So that's the features that we have for the calf. I will keep it like that. Let's dive into the heel modifications. Later on, you will see that we also have some buildups for other regions, but this is for the heel specifically. So we're able to modify the heel, more specifically really on the calcaneus. So adding material posteriorly. As soon as I applied this offset or this extra material, you notice that the total length of the foot also increases. So you immediately see what effect it has. And we can also apply it in the width so that it's not only on the posterior side of the calcaneus.
So Gilles, you actually bring up a really good point there. Sorry to interrupt you, but
no
these
problem.
Measurements historically in other like non-O&P software, the ability to capture measurements is kind of hard. You have to really know what you're doing. But we thought about that. We heard your feedback. And now when you're making changes to the patient's mold, you could see those measurements adjust in real time. So on these next few steps that you're watching Gilles explain, and we'll watch how those measurements are changing. And I apologize again for interrupting, Gilles, but it's a really good call out.
No problem. Thank you, Brian. But so let's continue to the toe box, where you'll see also a bunch of measurements and also a bunch of sliders. So there's a lot of controls for the toe box. To start with the extra length that we can add, we always start with 10 millimeter by default added. Compared to the landmark that we've placed on top of the big toe. So if I use this slider, you can simply increase the length of the toe box, and you will also notice that the total length of the foot also increases. So it has immediately an effect on all the measurements. You have sliders for the width, also the toe box height. So you have more control over the toe box height. Let's zoom in a little bit. So here you can see that there is still quite some space between the original scan and the mold that we're creating. So you can really use the overlays of the scans to achieve the most ideal height for the toe box. And then we also have these controls for the lateral and the medial shape of the toe box. So with using this slider, you can tell that this curvature increases a little bit, and there's less material added on the lateral side, and we can do the same for the medial side. So once that is done, we also have a lift, for example, that's something that we can also apply. Just wanted to show you that. So now there's a lift starting from the empty piece all the way until the end of the toe box. And now the last feature I want to share here for this step is the medial arch. As you can tell, it's not immediately activated, but just by clicking on this button, it is. And we do have some controls in order to choose the amount of, how hard or how intense the medial arch will be displayed or will be created onto the mold. So we have controls over the length, also where it exactly starts, the depth, and also the height. So with these sliders, you can very easily modify the height of the medial arch, etc. So really gives you an opportunity to really create a mold for each specific patient, but in a very structured way. And so once we have gone through all of these modifications, we can click on the next step where we have our final steps before we have created our digital mold. And the first one is these build-up zones. So as I said before, we already have one for the ankles, for the calcaneus, but we also have some predetermined zones for the malleoli, the navicular, and the base of the fifth. And so here you simply add the amount of offset you would like to see created. With the gradient, it's a bit more clear. And we can also change the zones itself. So we can really go and specify on some specific locations the exact amount of buildup that we need for that patient, or in case you work in a very specific way, you can always use the same amount of offsets in the same exact zones. So that's a very nice and very structured way of adding these buildups.
Yes, and Gilles, so you were really highlighting something very important there. A lot of our partners, they have a recipe for their molds, how they do things, their specific algorithms, for instance, of how much buildups and offsets they put on specific anatomy points. If you had those specifications and wanted your own custom mold to where your buildups populate on your mold, that's a service that we provide, and it allows you to go even faster here. So instead of having to adjust the shapes and the specific buildup amount, when you arrive to this step, it could automatically apply in those locations and amounts. So just want to call that part out, that we could truly customize the software for you as well if your volume justifies it.
Exactly. But so yeah, that's the nice thing about these zones, that indeed they can be customized. But also know that at the end of in the sculpt level, you also have the possibility to still add some local offsets in case these 5 zones are insufficient, or if you would like to modify some. But that's something that I will highlight later when we arrive there. Now we've added all the build-up zones. We can also apply a heel lift. This is something that can very easily be done in the software as well. You just indicate the amount of heel lift you would like to see added. I'll maybe increase it a bit more just to show what that looks like. And so basically it starts from the MTPs onwards, goes until the end of the foot, but you can clearly see that there is a heel lift applied. Nicely integrated into the software. So yeah, once this is done, we can proceed to the next step, which is where we have all these measurements to verify all the modifications that we have done. There are quite a lot, but you can very easily hide a few just to make it a bit more simplified. And in case you would like to double check the measurements that you also have taken from the patient, for example, just so you have a clearer view of how much change has actually happened compared to the original scan. You can also see that here, for example. Of course, this looks a bit strange, but it's because of the heel lift that we applied. But overall, I think the mold that we have created looks quite good. And I think I'm happy to validate and show you the last step, or the last level, which is a sculpt level. As I said, this can be used to apply some local offsets. So I always start by decreasing the exact limit. And so here now, once I draw on the scan, this means that I will not go above 2 millimeters. And you can really draw on certain areas where you would like to apply a local offset. Can also very easily be undone. Can also be done in the opposite way. So you can also push into the scan or create some pressure, for example. If I do it here, you can clearly see the difference. And another feature that we have here is the robust smooth. So it's not a robust smooth, but a smoothing function, which you are able to use and go over some areas that might need some smoothing. And you will notice that there will be some slight changes. It takes a while before these changes happen because we also don't want to make too drastic changes too quickly. So that's why you do have full control over the smoothing in this step. I'll just quickly undo that. So we keep the nice mold. And so yeah, if once you're done here, you're able to click next. You just validate one more time the modifications that we've done in the sculpt level. You click on save and exit, and we arrive back in the main screen. And here we have view corrected scans. You can immediately see where all the files are stored. I hope you can see this folder. Brian, can you just quickly confirm?
Yeah, we can see.
All right. Perfect. So here we have the raw scan. So that's the original scan that we started with. Then you also have the cleanup, which is the one that we got after the first step of the workflow, and then the mold, which is basically the finalized mold. I'll see if I can. So here we. No, I cannot put at the same time. But so this is the original scan, as you can see. And so if I open this, you can clearly see, all the differences with all the buildups applied, very easily accessible in the folder that you have selected in the beginning of the workflow. So that's a quick walkthrough of the footForma workflow of Spenties. So back to you, Brian.
Thanks, Gilles. It's some powerful technology. What you just saw was a semi-automated process that many of the digital innovators have been doing manually for the last 10 years. Finally, today, we have a process that is simple, quick, and easy to be implemented within a 5 to 10 minute process. So what happens after footForma, right? There's this open question of, do we go to 3D printing? Do we mill this mold and thermoform over it? What are we going to do after footForma? And that's what I have to share with you towards the end here. We are wrapping up our webinar, so if you have any questions, please put them in the comments so we could be able to answer them for you. And I'm going to zoom into the digital workflow. So if you're a clinician or a technician that wants to leverage this software, after the mold creation step, which Gilles just showed us, you have really two routes to go. Limited, but you have two routes to go that I'm going to share with you. You could always do more, but what I have to share with you today is the Spenties way, which is either using our design service, our 3D modeling engine, or 3D printing, or leveraging some of our partners that are also using footForma today that have carving and milling machines ready to receive your modified molds and mill them for you and either ship that milled mold back to you for you to do the thermoforming, or they could provide the full service for you to create your custom AFOs and other custom devices. Let's jump into the Spenties way. Now, the 3D model engine and the Spenties design service are incredibly accessible. We have with each of these processes, which this is what we're going to show you on the very next step. I'm going to zoom into it because I'm thrilled. If you've been following 3D modeling for custom made orthoses, which are then 3D printed for the most recent future. This is a order of magnitude more fast and simple. So I'm going to share that with you guys today, and then we're going to have a full release at OT World. But on the right-hand side, we have our smart order forms. You may see some of our CFAB partners white labeling this software and putting their products into the order management system so that clinicians could be able to quickly, easily order their orthoses and then track and manage them throughout the process. So that's here on the order management side. And if you have a custom fabrication service that you provide, we can customize this for you and connect it to all your other tools that you use internally. So let's zoom into this 3D modeling engine. I'm thrilled to share it with you guys. You're getting first looks here. It starts with this example that I'm sharing with you is a raw scan, and one that's not been modified. And we upload it to the engine. We've got many of the same tools and functions available to you in footForma, but what's really impressive here is we have automation to the max. I just pressed automate, and it's created my mold. It's created the trim lines for the solid ankle AFO and the molded inner boot, which I could go in and manipulate and change. Or on the left-hand side with my sliders, I could change, the offset, which is the distance between the limb and the orthosis, thicknesses, profiles, things like that. But after I specify my recipe, I press generate, and automatically the AFO and molded inner boot will populate on the mold. So an order of magnitude faster, and while maintaining quality, because speed's not the only part that matters here, right? You can't just go fast and then lose your quality. We must maintain quality, and that's why Spenty's approach is to automate first, define the recipe first, so that when clinicians or technicians are accessing the software later, they're only accessing the software within a predefined list of options. Can't really go outside of the capability there. So we're very excited to bring this to market. We believe that those that are investing in additive manufacturing today are going to want a very simple and easy to use digital workflow. And this new version of Spenty's modeling engine will be coming to you soon. Now, if you'd like to print with Spenty's, we are printing pediatric AFOs today and pediatric SMOs. We have a catalog full of devices that could be printed with you and for you if you so choose. But we'll leave that up to you. If you decide to use 3D printing, we're thrilled to be a partner, or if you'd like to leverage your existing CFAB manufacturing networks and their capabilities, happy to work with them as well. It's advanced manufacturing that's going to answer the challenges that we started this whole meeting off with. Now, when it comes to the business model, there are a number of different software business models in O&P. You have your per export, you have your license, you have sometimes, not recently, but about 10 years ago, you could purchase the software up front. And we are a SaaS model. So per user, $100 a month. There is no limit to the number of molds you create. We designed this business model so that you could receive your return on investment in 1 month. We believe that through the savings that you have on time, that return on investment will be there quite quickly if you have volume. But if you're a clinician that has been avoiding creating your own modifications because the molding process with plaster just takes too long and you've got a lobby full of patients and you just don't have time for it, then for $100 a month in a 5 to 10 minute workflow, you can upload a scan, export a mold, and send it for fabrication. And we believe that this is going to help the industry address many of the challenges that we're all facing. Now, for those that did not do that Irish goodbye and are still with us, you have access to free 2 weeks of our software. You could be able to right now put your email in the chat, and after this webinar, we're going to immediately activate your account, send you a link to download Forma. And if you have a scan of a cast, you could be able to explore Forma today, you know, figure out the range of its capability from more simple to some of the more complex things. You could see it today. So we'll activate that trial for you, but you have to put your email in the chat right now so that we'll send it to you afterwards. And we'll also schedule a training session. I think that's important. If you have colleagues that aren't able to attend the webinar today, and you'd like for them to also have access to this software for this trial, then let's schedule a training session where Gilles and myself, or Thomas, or Gilles will be able to train your team on how to use this software effectively, and in your trial, put together some goals and objectives so that we can measure how the trial was for you at the end of it. So that is footForma, and I, like mentioned at the beginning, I'm thrilled to introduce it to you. We first launched this software back in June of last year, and it's gone through a series of impressive updates. So what you're seeing today is a labor of love, and we will continue to optimize it and make it amazing. So with all that being said, if there are any questions, let's just jump right into them and go from there. Let's see, Gilles, are there any questions here in the chat? Okay, a number of them.
A number of them, yeah. I think we tried to answer already a few of them.
Yeah, on scan height, when Sean asked scan height and the ability to adjust the scan height, you showed how to go lower. One thing that we could do, Sean, I'll send you a quick video of that specific step of the workflow to where you could be able to extend it if you so choose. And then measurement of the height, yes, we have that. One thing Gilles maybe did not specify in his demonstration is on the right-hand side of Forma, there's a couple of icons that you could be able to click on and pull up measurement tools on demand. So if you're at a specific step and you want to pull up a circumference or a length, you could do that on demand within Forma today. I liked Alan's question about direct limb scanning. Absolutely. We believe that that's a good way to save costs as well for clinicians and technicians if you're scanning direct limb. But for pediatrics, I'll say, it's been historically challenging to scan little kiddos directly. So I'd say 90% of our partners today that are using digital modifications and advanced manufacturing for pediatrics are casting their kiddo and then scanning the cast. But we love direct limb scanning because that saves time and money. Can you create a shoe last and print the positive, print or mail the positive? I think the answer is yes. I think by the end of that demo there, you saw where that shoe, we call it a mold. We could also call that a shoe last, but if you'd like to explore, Mr. or Mrs. Rosenbaum, how the tool can create your shoe last, let us know, and we'll definitely put that trial in your mailbox. Superimposing the scan, I think maybe that question was asked before you started showing what the mold in the scan looked like superimposed. So yes, we could do that. Yeah, the adjustments, okay. Is there an option for exporting data specific for each mold to help bolster documentation for CMS reimbursement? That's a really great question. Data is going to be one of the core, the difference between clinics in 2026 that access data versus those that do not. Well, this is not a webinar for that difference, but you can always take screenshots of that measurement validation step. You could always superimpose the original to the modified, but this is a great question for some extra thinking on, Alan, what you think a better or a more robust way of capturing that data would be. Direct limb scan, Stephen, yes. adults. There is no limit here on footForma. You could be able to upload a scan of a 1-year-old or a much older, heavier patient. There is no limit on the software there. Now, for additive manufacturing, it comes to a limit of real estate. You only have so much space in a 3D printer that could fit a custom-made device. So we're getting creative, and we're using PDE struts and to get to those larger sizes. But if you were to leverage Spenti's additive manufacturing service, 3D printing, there are limits to the 3D printed models, and that's okay. Combo pricing option for footForma and the software, also AutoForma. So Spenti's has AutoForma, FreeForma, and footForma. This is all a part of the Forma family. Auto and FreeForma are for upper extremity orthoses. And yes, we could do a combination plan for you, Alan, so that you can access all of those.
All right.
Okay.
Is the calf offset another term for adding a roll top to the finished product? Yes.
Well, roll top I'm not familiar with, but it's really what that calf offset is it's really creating like a flare, right, proximally. So if you want to flare the proximal end of the scan, you could do that with the calf offset and change the length and height and amount of that in that stage.
Any scan formats can be used to operate this footForma, or is there a specific format required? I think it's OBJ and STL that is possible with footForma. I think that's about
it. And also
it for
PLY.
Is it PLY already as well? Okay, so then we have those 3 files that are available or possible with footForma. Any upcoming options for KAFO modifications?
That's a great question. We don't have KAFO specifically in our roadmap. Not to say that we won't do it. We have our partners are really dictating the direction of where we're going. And currently at the moment, we're focused on AFO, some prosthetics, and we can always add KAFO. If you guys were to become a partner of Spenti's and you say, guys, I need you to do XYZ. I love the idea. I love the UI and how easy it is to train people, but I need my products there. I need my processes there. Then Spenti's has a customization service where we could be able to customize the software for your specific organization and build technology for you. That's one of the core unique differentiators from Spenti's than anyone else in the world, is that we are not just providing off-the-shelf solutions. We are a custom software developer. So that could be something we explore in the future.
How will we do the digital modification if we scan over a cast? Do we need to follow any specific guidelines? Do you have any guidelines of this? I'll take that together with the last question as well. Is there any patient weight limit to use the final product from footForma? I mean, guidelines, we already have structured our software in such a way that you start from the beginning. So you first clean the scan, as I've explained in the workflow. So normally everything is nicely set up for you to create your own digital device in a very structured way. So I think in that sense, we do have a nice guideline to get to the final product. We also have a lot of extra information about that on our help center, so you can always access that in case necessary. And then in terms of weight limits, I think as Brian already explained, for our additive manufacturing products, so our orthoses products, there are some weight limits for certain products. For the footForma tool, however, it can be used from kids to adults, so not really a weight limit to it, let's say.
Well, I'll zoom in on the additive manufacturing weight limits. So for our articulated AFOs, 140 pounds for solid ankle AFOs. Is it 140 pounds as well, Gilles? Is that I'll take it on, but I should have known.
Yeah, I think everything is 65 kilograms except for the B2. So the static AFO, so it's 140 pounds. And then for the static AFO, it's 45 kilograms. So that's, I have to think about it in pounds.
Okay. Yes. So for the line of the Spenty's line of 3D printed devices are really for kiddos. And there's really not a length limit. It's more of a weight limit. And we figured out those limits through our R&D process. So testing, cyclical testing, lots of testing. Let's keep on rolling. So Dennis has been scanning directly on children for years. I would love to figure out how you did that, Dennis, and how you do it on a regular basis, because a lot of times our partners, especially new clinicians getting started with digital workflow, it's like a game with the kid. Is you got to keep them distracted, maybe with some candy or a screen, and you just say, okay, hold still. And I think your scanner really matters a lot if you're scanning direct lin for kids too. Stephen, if using Spenty's for additive manufacturing, where does the product come from? Now, we have a couple of different manufacturing sites that we leverage. I'll speak to the ones here in North America. So we're printing in Texas and we're printing in Minnesota and shipping all 50 states as well as Canada. We've done some production for Mexico, but not much. So we have 2 manufacturing sites here. But if you have your own printer or you have your own partners that you prefer to print with, you can also leverage our design service, download the file, send it to your partner. So we're a software company. That's what we want to be. And we want to enable you to be able to access the value, the full added value of additive manufacturing. And if you need print service, we'll offer that for you, and we'll be as competitive and try to have a lateral move to your traditional fabricated orthoses today. But if you want to go and buy printers yourself, you're more than welcome. And Gilles, maybe for the manufacturing sites in Europe or site?
Yes. So we print together with Rep Center in Netherlands. So that's what we use for the distribution in Europe. So yeah, here we ship all over Europe, coming from the Netherlands. So that's it for here.
Got it. Alan is a solo practitioner with a mobile outpatient physical therapy practice. Could, if becoming a partner of Spenty's, which we hope you do, can you use the final molds and patient demos for marketing? Yes, absolutely. And again, if you want to create your own line of 3D printed devices, like your clinical standards, your parameters, your logos, your branding, your workflow completely branded to you, and you want to go to your referral partners and your therapist, which Alan, I see you're a therapist yourself, but you can always go to them and say, guys, we're innovating. And we, in addition to our traditional and fabricated devices, which have worked well for so long, we're now offering a new way of doing things. So we're seeing that work out very well for the partners that take on that service. And we're just in the background as your software partner, making sure everything's running well and to your standardized approach. And you get to get all the credit with your partners. And that's nice. Can I market the devices by showing the printing process here? Yes, absolutely. Now, 3D printing, custom made AFOs, I would recommend to fall within some validated parameters. I know there's a lot of movement right now for people to try to print with FDM printers as materials are advancing. But I would lean into powder-based fusion technology, as that is what we have designed our devices for, and have all the data supporting the clinical efficacy and the structural integrity, and that's what we're seeing today. So yeah, that is a a weight limit based on the space in the printer or the material. It's really a mix of both. Real estate in the printer really limits us, maybe not limits, but constrains us to the size of device that can be printed. But again, we address that oftentimes with some innovative design. But the powder-based fusion print technology is also based on the patient's profile. So we're designing orthoses. If you leverage our design service, you're indicating the patient profile, and then we're using our validated set of parameters to design the device around that profile. So if you tell us that patient weighs 100 pounds, they are a highly active kiddo, their age, the indications that they have, all that data goes into generating the device for you, based on our testing and expertise with printing these all across the world. footForma is only. Sorry, Gilles, I'm taking all the questions.
No problem.
You take this last one from.
Is footForma only for orthoses? I think that's what it primarily is used for at the moment. So it can be used to create your own digital mold, and then either to carve out and then to shape the orthosis around. But if you're talking about other products on the market, such as insoles, for example, I think it could also be used for that, but it's quite a complex workflow in order for you to be able to create insoles, for example. So I think primarily it is used indeed to create orthoses, let's say, but can also be used for other things, of course. And do you have any plan to design prostheses in the future? This is we are active in the industry, so we have already done some projects both in orthotics but also in prosthetics. So we are working with partners that provide prosthetics to their patients. Will we create something of our own? That's something that we cannot tell at the moment, but we are definitely active in that area, gaining a lot of knowledge. So yeah, who knows what will happen on that part, right, Brian?
Yeah, well, I'll just say our engines have been producing prosthetics for a couple years now. But because Spenties is, like I mentioned in this webinar, we've done a lot of custom development for our partners. You may not see everything that we do because we're behind the scenes, and we take a lot of pride in that. So with all that being said, I think we have a lot of emails to send some follow-ups to, but if you'd like, I'll give you one last opportunity to take advantage of this 2-week trial. If you've not yet put your email address in the chat, then place that there now so that we'll send you the trial and follow up with you very closely. It's been our pleasure to introduce you to footForma and to share a little bit of the why of why we exist. And I know Spenties, we make a lot of noise on LinkedIn, but it's because we're truly passionate about helping clinicians and technicians embrace the future. And I hope that we could be able to help you and your team fit some great patient cases soon. Gilles, any last words?
No, I think everything's said. I would like to thank everybody for joining us on this webinar. It was nice to see all the questions coming through. I hope we were able to answer all of them. If you do have any other questions, don't hesitate to drop your email and then send them to us through mail. We will be more than happy to reply there. But so yeah, as I said, thank you very much for joining. I see that we also have reached the end of the webinar. So thank you very much, everybody.
Take care. Bye-bye for now.
Thank you.